Welcome back to NPTEL assignment series. Assignment number 7, question number 5. Here the question is, consider the operation amplifier based comparator as shown in the figure, where the operation amplifier operates in the saturation region. The question is, what is the value of V0, output voltage? When the operation amplifier used in comparator mode, it will give only two output. One is plus V saturation, another one is minus V saturation. The saturation voltage will be the maximum of plus VCC and minus VCC. So plus V sat is nothing but plus 5 volt and minus 5 volt. These are the two possible outputs. Plus 5 volt is possible when the positive terminal input is greater than the negative terminal input. So V1 is applied at a negative terminal, and V2 is applied at the positive terminal. So V1 must be less than or equal to V2. And similarly, for second case, minus 5 volt or minus saturation volt is possible when the negative terminal input is greater than the positive terminal. So V1 is applied at the negative terminal, that must be greater than V2. V2 is applied at the positive terminal. Okay, so here plus 10 is applied at a negative terminal and plus 5 is applied at a positive terminal, so that V1 is greater than V2, which means the negative terminal is greater than positive terminal. Therefore, the given answer is minus 5. The next question, question number 6. Consider the circuit as shown in the figure and answer the following questions 6 and 7. Okay, here it is square wave generator. The circuit will generate the square wave. Here the first question is the value of Vp, the voltage at this point. By assuming V0 is driven by plus 5 volt at the start. So if V0 equal to plus 5 volt at the starting point, then we have to apply the voltage divider rule. What is the voltage at point P and ground? That is Vp. Vp equal to the resistance across we are measuring the voltage is 5 kilo ohm divided by the total resistance is 5 kilo ohm plus 10 kilo ohm. And the total voltage is plus 5 volt. That is V0. Okay, so V0 is plus 5 volt. I am writing directly. So 5k by 15k into 5. 3k is getting cancelled and we are having this 5 by 3. 5 by 3 is 1.67 volt. The option is B. To confuse you, we are having 1.67 millivolt also. Here the answer is 1.67 volt. Don't confuse. Okay, so the next question, question number 7. The frequency of oscillation for the square wave generator shown in the figure. For the square wave generator, what is the frequency of oscillation? That is nothing but that is given by the time period. First we have to calculate the time period t equal to 2 RC ln of R1 plus 2 R2 by R1. So the values of the resistance, this is R1, R2, R and C. Okay, so I am applying the values. R equal to 5 kilo ohm, C equal to 0.1 microfarad. 5 kilo ohm into 0.1 microfarad into ln of R1 is 10 kilo ohm and R2 is 5 kilo ohm. 2 into 5k divided by R1 is again 10 kilo ohm. So the answer is 5 into 2, 10k into 0.1 microfarad. So it is 10 power minus 3 into ln of 20k by 10k, that is 2. So the answer is t equal to 0.693 millisecond. Use the calculator in the appropriate mode. And what is f0 equal to 1 by t, that is equal to 1 divided by 0.693 millisecond, that is equal to 1442.69 hertz. That is nothing but 1.44 kilohertz. So the answer is option D. And the last question, the frequency of oscillation for the simplified triangular wave generator. Okay, so this part is integrator here, and this part is nothing but square wave generator. Okay, so for the integrator, if you give the square wave as input, that will be converted as triangular wave. So here the triangular wave output they are asking, what is the frequency of oscillation for the circuit? T equal to the time period t equal to 4 R1 C1 R2 by R3. Okay, so here this is R1 C1 R2 R3. Okay, so it is 4 R1 is 5 kilo ohm, C1 is 0.1 microfarad, R2 is 5 kilo ohm divided by R3 is 10 kilo ohm. So if you simplify this, you will get 1 millisecond. t equal to 1 millisecond, and f equal to 1 by t, and that is equal to 1 by 1 millisecond is 1 kilohertz. So the answer is option A. Thank you.